Thank you for joining. I'm Tim Titus, Chief Technical Officer and founder of PathSolutions. What we're going to do now is go into a demo of TotalView and see how it's able to find and resolve problems in a network. First thing I'll talk about is the installation. The installation is a lot faster than a lot of other products because our entire solution is an 80 megabyte download. And I said megabyte, not gigabyte. So it's very compact, very efficient. There's no external libraries you need. Nothing else is needed. You don't need a web server. You don't need a database. Everything we need is self-contained. So we have our own web server. We have our own database, and it's all compiled into the same application. What that does is it means that there's less stuff you have to worry about. Let's say when a Microsoft update comes along, this isn't going to fall like a house of cards. A lot less administration, a lot less concern about security exposures because our database is compiled directly into the application. There's no external ports for our database. And if you're curious, we use SQLite as our database, so it's compiled directly into the application. We get some great performance out of that, which gives us incredible scalability where a lot of other products just can't scale as large as we can as a result. So you install, and what it's going to do is it's going to get to work and go out and scan the network and find all of your switches, routers, gateways, servers, anything that's out there that responds to SNMP. We're going to find it and automatically start collecting information. Very quickly, it's going to find problems as it collects information. So again, you don't have to configure individual OIDs. It's going to be searching for problems, saying, gee, we found a problem on the Syrah switch. And actually, one thing I'd like to do is talk about SNMP really quick. We support V1, V2C, V3, including the high encryption that Cisco has beyond the standard of V3. So effectively, any SNMP flavor you prefer, we support. So the Syrah switch has a red dot. We found a problem there. And so you can click into that switch and you're going to see all the interfaces on that switch. Here we see interface number 5 has a red dot and it has 4% packet loss. Now, if I told you, hey, we found packet loss on a switch port, I think most folks would say, so what? That's probably a printer. Maybe it's a photocopier. I really don't care about that. If this is a trunk port or there's a critical router plugged in here or a gateway or some server or somebody's VoIP handset, then I'd say, yeah, you probably need to fix this. So depending upon what's plugged in here drives the criticality of the fix. To that end, we expose all of the CDP and LLDP information, if any exists, to show you what we see upstream on that connection. Additionally, we have a fully integrated port mapper. Click on the Connected tab, and we're going to show that that interface has one MAC address. That MAC address associates with the HQ voice VLAN, VLAN number 110. We have the MAC address. We can see the manufacturer of the device. We have the IP address, and we have the reverse DNS. Okay, so this is our voicemail recording server. Now that we see what is affected, I'd say this is a high priority problem because any voicemails are going to be choppy due to that packet loss. So let's go see what the problem is. We click into the interface and we see the utilization graph. Below that, we see the packet loss graph. And then below that, we see the plain English prescription. And here we're being told that we have a cabling fault. So it's that fast and easy to detect that we have a problem on the Syrah switch. We have a problem on interface 5. The problem relates to packet loss. It affects the voicemail server. Here's when the problem started, here's when the problem stopped, and here's what the problem is. Something to recognize is that we detect this problem, whereas a lot of other network monitoring software packages might not even be aware of the issue. Here's why. If we click on View Error Counters, it's going to show us all 19 of the error counters that we're picking up. A lot of other network monitoring products, they might only look at inbound errors and outbound errors. And so they're going to declare this interface as healthy if the interface is even being monitored. Since we're monitoring every interface in the network and we're going all of this depth, 19 error counters worth of depth, we're able to say, no, actually, it's not healthy. You've got a ton of FCS errors, some deferred transmissions, some outbound discards. And by the way, Here's what all of this means along with the configuration is any seasoned network expert would say, hey, when you have FCS errors and you have no alignment errors on an interface, the first thing you should suspect is you've got a cabling issue. But if you had FCS errors with alignment errors, but no collisions on the interface, you'd more than likely be dealing with the full duplex side of a duplex mismatch. The purpose here is you don't have to crack open the books to say, what do these error counters mean? You're able to get the problem resolved because you're led to the plain English answer. This also means the entry-level help desk folks can work on fixing the problem, and it doesn't have to escalate inside the organization. If you want to learn more about the error counters, though, we've built in an engineer's library. Click on the error counter, and it gives you the official IEEE definition, a more basic lay definition, and then what you should do to solve the problem, all of the different causes. So you never need to go out and search Google or Wikipedia to find out what does this mean. All of the information is built in. So with all of these error counters collected on every interface of the network at every 5-minute period, what this means is if you drop or buffer even a single packet anywhere in the network for any reason, we know when, where, and why that happened. So let's put this together and do a root cause troubleshoot. I'm going to go to the Path tab, and let's say we had a problem just before noon between a user's PC and a gateway. We can put in the PC, put in the gateway, and click Map. What this will do is look at the routing tables, bridge tables, ARP cache, and spanning tree and determine how do these two devices talk to each other. Here's the PC. Looks like it's plugged into the Pino layer 2 switch, and it's connected to interface number 7. Over the past 24 hours, that interface looks perfectly healthy. Again, perfectly healthy by our definition means perfectly healthy according to all 19 error counters. Other products, if they say an interface is healthy, I found it really sad is other products will say an interface is healthy, and yet you've got collisions up the wazoo that are tracking on the interface, and it's just not aware of it. So we're able to give you confidence that that actually is a healthy interface. Outbound, it's going out through interface 25, and that interface has some high utilization, but there's more bandwidth available, and there's no packet loss. So that's a healthy interface. Inbound and outbound on the Syrah switch looks good. Outbound on the Burgundy switch going out interface number 3. Looks like we have some packet loss going on, and it looks like right before noon, we had 6% packet loss. So it's that quick and easy to target in and say, hey, this is a suspicious interface as to what caused their problem right before noon, because this is the interface that was dropping packets. So we can click in, read the plain English prescription, and get the root cause of the problem solved. I'm not going to stop troubleshooting here because I want to continue to see if there are any other problems. And we quickly determined that inbound on the Santa Clara router, we're dropping a little bit of packets as well because it's running half duplex. That's a quick, easy fix. I see that the outbound interface is configured for class-based QoS, and there's a high priority voice queue and a default queue. Our problem is the high priority voice queue isn't taking any traffic. So that means if this was a voice call, that all of those voice tag packets are dropping into the default queue. That's bad. We can click, it's going to jump into the QoS section, and we're going to be able to see that the problem here is it's matching DSCP AF13, and it should be set for EF. So at this point, we log in, change the policy, change the class to be able to match EF, and we're going to start seeing some voice tag packets hit this queue. So that's how we can root cause troubleshoot every link, every switch, every router used between a pair of IP addresses with 19 error counters worth of depth, all the QoS, all the performance, all the configuration at any point in time previously. A few other bases I'm just going to cover really quick is things we can do is we have a dynamic network map that shows a live look updated every 5 seconds. Live look into your network so you can see what devices are available, what links are available, what problems exist so that you can say, I can see what's working and what's not. We have an automatically generated network diagram that shows how your network is connected. So if you ever want to have an understanding of where subnets are, where devices are, if you want to change how this views, if you want to download to Visio, you have all of that ability. We have a correlation engine. If you want to see what happened at a certain point in time, you can choose 15 minutes ago, and it's going to show you all of the events that happened 15 minutes ago within a group. You can choose the grouping over here on the right. For all of the devices in our environment, we're tracking traffic levels, PoE levels, spanning tree information, full inventory off of all of these devices. We can automatically back up configurations and make large-scale configuration changes by the fact that we include network automation as part of the core package. We include Netflow as part of the core package, so you can see who was using bandwidth at a certain time, what were the ports in use, TOS settings, protocols in use, and users. And IPAM. Everything you need for IPAM built into the product and integrates to Microsoft DHCP to show how is the DHCP scopes allocated. And down here we get to the purple section and we can see the lease times on those scopes. So again, to summarize, our core trick is automate, automate, automate. Get as much information automatically collected and also pre-analyzed so that you have answers in front of you rather than, well, I've got piece A and piece B, and I have to put it together to say, what do these two pieces mean? So at this point, I'd like to open it up to questions.
Hi, Tim. This is Tom Green from Tom Talks Tech. I was curious, on the map you showed there was a link down between headquarters and
Texas.
a remote site. So whenever you're troubleshooting that, do you get the data that happens between the outage and whenever it gets restored? What happens to that streaming data coming back to headquarters?
So the site in Texas is down, and we're unable to collect information from the devices that are in Texas. So we will show an outage. We do have parent-child relationships so that you can determine and say, gee, I don't want 40 alerts based upon this outage. I want to see the alert that caused the outage. So you can squelch those alerts with parent-child relationships. But what was the question again?
So whenever you get the alert, there's no connectivity between Texas and California. What happens to the data that's still being generated? Because you're assuming Texas still has machines running inside of it. Is there any way to diagnose those after the fact to see if something on the inside of the Texas data center caused problems?
So you can set up another deployment of TotalView. We don't have we don't charge for licensing that way. You can actually split your license and say I want 3 deployments versus I want 1 deployment. So we don't charge per deployment, we charge per interface. So you can say I'm going to split this and say I'm going to have a deployment in Texas collecting its information. So even if that link is down, that information still comes back to a server in Texas.
And then if you have that split, does it all aggregate into the same panel so you can look at all in single pane of glass?
So I'm going to say is some of the information is aggregated, some of it is not. And so I'm not going to say it's perfect single pane of glass. We're moving in that direction. We're almost there. But I can't put a sales hat on and say, of course it's all aggregated. There's some information that is still separate, but we're working towards that goal.
Great, thank you.
Tim, this is Terry. You have a bunch of mechanisms to gather data, or you have primarily relying on SNMP. Do you have other mechanisms like CLI? Can I go get information from these devices using that mechanism? So what I'd like to do, let me paint a little bit better scenario instead of just asking that one yes or no question. What I want to be able to do is run commands, collect the output and store it somewhere, because I might want to be doing some pre-change analysis of the network and making sure that it has a certain set of characteristics and certain routes exist, et cetera.
So yes, that's part of our network automation capability. So I guess I'll talk about what we do in network automation. So we can do automatic scheduled backups of switch, router, firewall configurations. We can also do automatic backups upon change, so that if you end up going into a switch, you make a configuration change, as soon as you exit config mode, we're going to make a backup of that device and say, by the way, here are the 3 lines of configuration you changed, so that you get an email, or I should say that the appropriate team gets an email notification and say, Terry made these 3 changes on this switch, so you get that notification. Additionally, if let's say you want to collect information from switches and say, I want all of the SNMP configuration information brought back for this group of switches, or all of the Nexus switches in our environment. You can automate having that information collected and stored. You can also automate getting, let's say, 100 lines of ACL that you want to say, I want this to go out to all of the iOS-based switches in the New York office, and you can end up making that sort of selection. So there's a lot of automation capabilities built into our CLI mechanism.
Okay, thank you.
Well, that triggered a follow-up. Pete Welcher here, Net Craftsman. Something I've been doing in various forms and finding kind of useful is to build a list of show commands, thinking Cisco routers here and switches, and blast them out, including ending up with a show run. Also, I include a separator. I capture all that to one file per device. And that saves me a lot of connecting to devices to check things. In addition, it gives me the ability to do things like use Linux commands, do a grep across all the files to see who's got a route to this destination, that kind of a thing. It's turning out to be pretty handy. Could I do that with the automation capability?
Yes, you can collect the information so if you put a set of Unix tools on the Windows box, then yes, you could end up having that same sort of capability. So the collection of do the SSH to these 20 selected switches that match this criteria, that match the iOS version or match the NX, the OX version within a group area. So we allow that collection to happen automatically. Then you would end up attacking it with your tool set.
Yeah, as long as I can get them one file per device in a folder, then I've got Python and Perl scripts that I can use. That's the reason for having a uniform separator, is I can pick up show as a start delimiter and the separator as an end delimiter and pull out one of the show commands and turn it into a table or something like that. And I've been recently playing with the Windows subsystem for Linux and having some fun with that. So that's another possible answer.
Yeah, yeah. So actually, talking to that, I'll admit that I longtime Unix fan. In fact, if anyone ever wants to talk about BBSs, I set up a Unix bulletin board system back in the days of dial-up modems. But one of the things I was always loved is that storing configuration information in configuration files was very easy to work with, because you can do grep, you can do search and replace, you can do all sorts of powerful things with it. The underpinnings of our product, we don't hide our configuration information in a database. All of our configuration is stored in configuration files, meaning you can end up doing grep searches and replaces, all sorts of things, because we allow that open to people to make those changes. And we figure it just means that faster configurations can be implemented with our product as a result of storing it that way.
Could you describe the file structure? Is it a folder per date of collection with files in it, everything that was collected on a given date, or is it broken out by device?
So, okay, so the data that is collected is stored per device in a single SQLite database file. So we use a SQLite as our database. The configuration, though, is stored in text configuration files that are tab delimited.
Okay, but the question is, what's the structure above those files? So are they stored in a folder by device, or are the files stored by date?
Are you talking about the data or the configuration files?
The configuration files.
Okay, the configuration files are stored in one configuration file for the entire product for that feature. So effectively, if you're looking to say, I want to change an interface description of how TotalView displays a description on an interface, that's an interface description.
I meant the actual router configuration files, the backups.
Oh, okay, the router configuration files, those are stored in a directory per device. And it effectively does that by device name and then date. So effectively in that same directory, device name, date.
Well, and a competing product does something similar, although I think in the reverse order, and doesn't consistently store by date. It only stores when there's a change. So I've had experience with unflattening it. You can, or with flattening it so that you can get at things. So as long as you have the data, you can work around however it's stored.
Yeah, you can so I've done scripting before where you can say, get me the latest copy of each of these files, and then you run a grep against the latest version of those files. So the great thing about command line and PowerShell or even Windows CLI or any of the C shell or any of the Unix shells, incredible power once you've learned the tricks. But as we've all learned, is with great power comes great responsibility.
Yes, I trust your admin has given you the usual talk. So I guess this leads on to kind of an interesting intersection. We were talking about vulnerabilities in a recent conversation, and the idea of configuration archives. Now, these, from the sounds of it, the configurations you're grabbing are available on the actual TotalView server, but are not exposed via the web interface. Am I interpreting that correctly?
Correct, yes.
On your super secret squirrel roadmap, which none of us have seen, are you envisaging a point at which configuration archiving and diffing and so on might become available through that web interface as a function? If you're grabbing them, they're available, and it's like it's right there. It's just a few clicks away.
So yes, with an asterisk, the asterisk is properly secured. Yes, we're interested in doing that. We haven't finished the discussions about properly secured because that's something that recently a monkey wrench has been thrown in, is to wanting to make sure everything is properly secured. So we want to do that. It is interesting to do that, but it's got to be done the right way.
Yeah, I mean that's the kind of thing where there's a lot of power in having that available, both through the web interface and ultimately through a REST API. And again, this comes back to role-based access control. So when you're mapping that, yes, it's permissions back to yes, who can see the interface to troubleshoot by all means, and then yes, who can actually see your configurations. And that may be something we probably didn't touch on, but in terms of access control to this, I'm assuming you can map to LDAP and Radius and so on.
LDAP, yes. Radius, no.
Okay, so with LDAP, but can you then, beyond that, is it just a straight authentication, or is it a group? Can you map to a group to say this person can do certain things, or?
Yeah, so you can map to groups. So you can say this is the help desk group. They have access to these. So you've got all that capability.
Okay, awesome.
So in terms of growth ambition, you no longer want to be the next SolarWinds.
No, honestly, what we want to do is we want to help people solve problems. Honestly, if we can do a deployment with a customer and have them learn and say, oh, I didn't realize these 5 things were happening on our network, and we help them fix that on an individual customer basis, that keeps us happy. That's kind of what motivates us. So whether we have 2,000 customers, 20,000 customers, we're focused on trying to fix the problem, but growing big creates problems if you really think about it. And so we all want to be lean, mean, and end up having a small but efficient organization, and we don't need to be the next big SolarWinds company.
So Tim, I have a question about your network discovery mechanism. In a number of networks, they use a variety of SNMP credentials. Can I put in a whole set of credentials and have it automatically figure out which credentials work? Because that's a real pain, having to say, oh, this device uses that credential, this other device uses this other credential. And then the other thing is controlling the scope of discovery. Tell us a little bit about how you prevent us from going out and trying to discover the ISP's network.
Boil the ocean, that'll work. So, Terry, you and I think alike because effectively we came across the same sort of problem is you've got a pile of community strings because you've got companies that acquired other companies and you've got community strings all over the wazoo. And you also kind of want to scan to determine who's responding to public because you'll discover all sorts of ugliness in a lot of networks that way. So what we do is with our discovery is you put in all of your community strings, all of your different credentials that you want it to look for. There's some optimization that can be done if you say, okay, let's use the most frequently used at the top of the list so that it's going to be able to use that. But it's effectively like a janitor with keys on a keychain is we're going to go through and say, does it respond to this? Does it respond to this? Oh, it does respond to public? Okay, we're going to monitor it and make sure you know that this one's responding to public. But what that means is you're not having to do multiple scans. We're just going to do one scan and say, here is everything that responded and you're auto-configured, no matter what the community string is.
Yeah, well, that also means that your security group is going to get an alert when it fails.
You would hope that they would, and in one sense, this is only done during an initial deployment. And part of our deployment sheet, we have a question saying, have you notified your security team that we're going to be doing this scan to discover devices? Or do you want to find out if they determine you're doing a scan to test?
Yeah, I used to ask that as a question when consulting. Do you want to see if your security team is awake, or would you rather they not?
So the other question was, how do you limit the scope of the discovery?
So limiting the scope, the way we have it is you put in subnet ranges that you want to scan. And so therefore, if you know that you're saying, gee, our 10.1.0 subnet, we don't even have to scan the full class C subnet because you know that the upper end is all DHCP. If you only want to say, we're going to scan the bottom 20 addresses, you can limit it to say, scan this class C, but just the bottom 20 addresses. Okay. So it's lightning quick for finding the network infrastructure devices, which is all you really need to be able to see what's going on. We can tell you what's plugged into the switches once we have that bridge table out of that switch. So it speeds the deployment where we actually have a lot of customers that have very rapidly deployed solutions where they'll deploy and find out, gee, within the first hour, I'm seeing more of my network than I've seen with any other product just because of the depth and breadth of the collection.
Okay, thank you.
Well, folks, thank you very much for your time. Really appreciate it. If you want to learn more about the product, go to www.PathSolutions.com. We have videos there that explain more about the product. We also have a sandbox if you want to play around in the sandbox and see how this works, or reach out to us and we can get a technical demo for you. Thank you very much.